In this video, we are going to look at a question under calculus that tells us to evaluate the integral of 5x plus 8 over x minus 1, x plus 2 with respect to x. Now, when you look at this question that we've been given, it's actually partial differentiation, partial fractions or integration. So step one is branch this into partial fraction. If you don't know how to do partial fractions, that might be a challenge a bit, but let's first do it. All right. So we have 5x plus 8, follow me properly, x minus 1. All right. So branching this, since the factors are linear, it will be easier. Okay. So the easiest way I do this is just get this here, say equal to 8, then multiply a and the denominator of b, then multiply b with the denominator of a. That's all. Then these are linear. So say when x is 1, set this equal to 0, set that equal to 0. What is the other value? So when x is 1, here you get 5 plus 8. There you get 3a. Right? And here you just get 0. Therefore, here we will be getting 13. Right? We're getting 13, so 3a is equal to 13. So over 3 over 3. So our a is 13 over 3. Now, most of you feel like you are doing something wrong just by finding a fraction. No, you're not doing something wrong there. All right. Next, when x is 2, sorry, is negative 2, if you set that one equal to 0, what is b? So if I put negative 2 here, I'll be getting negative 10 plus 8 equal to, if I put negative 2 here, this becomes 0 plus negative 2 here, this becomes negative 3, then b outside. This will give me negative 2 is equal to negative 3b. All right, of course, divide by 3 throughout, you get b is 2 over 3. It's time now to replace in our equation there. So we go back there and replace. All right. Our a is known is 13 over 3. So this becomes 13 over 3. And 3 will multiply the denominator. And this one will be 2 over, the 3 comes down. So we have branched that into partial fractions. Then the next step is now to integrate. Meaning if I'm going to integrate 5x plus 8 over x minus 1 and x plus 2 with respect to x. It's the same thing I'm integrating 13 over 3x minus 1 plus 2 over 3x plus 2. It's the same thing I'm doing this. Okay, this is why partial fraction integration is very important and useful. It's the same thing that because this one has been transformed into this partial fraction, you can just add the integral. Now the integral can be distributed throughout. So let us now distribute the integral throughout. Okay, so we get 13 over 3, then x minus 1 with respect to x. So you can integrate like that, then say plus, then have 2 over 3x plus 2 dx. The integral is not stingy. You can actually distribute it throughout. Then I think from here you know that this is a constant. 13 over 3 is a constant, so take it out. You have 1 over x minus 1 dx plus 2 over 3 is a constant, so take it out. Then 1 over x plus 2 dx. Trust me, you can't fail to do this now. Okay? At this stage when you reach, recall the derivative of 1 over, let's say, x with respect to x. What are you getting? You are getting natural log of x. Right? Just the natural log of x. It's the same thing here. Here. As long as there's no square, if there's no square, don't even waste time. Just get the same. But if there's a square, you may need to differentiate this first and so forth. Yeah. But we're going to skip that anyway, because 13 over 3 should be outside, then 1 over this If you use substitution, if you use substitution, you are still getting back the same answers. There's nothing here. All right. For those who don't know what use substitution does, helps you. If I have this dx, I'll let u be equal to the denominator. Then I'm going to differentiate that with respect to x. So you see that du is just dx. So meaning I'm going to have 1 over u. But what is dx? Dx is just du. And recall what I said here. The integral of 1 over x or 1 over u, or as long as it's a single letter, it's just the ln of that letter. All right? Meaning here I'll be having the integral of, so if I integrate this with respect to u, I'll get ln u. Right? But what exactly is u? My u is x minus 1. So instead I'm still just going back to the same, right? So we can now say the integral is 13 over 3 natural log of x minus 1 plus 2 over 3 natural log of x plus 2. And I'll say plus c. This is an indefinite integral, so I'm going to add a constant of what? Integration. That's all. It's done.